Okay, hi. This is going to be a general overview of MATLAB. Hopefully, um, Friday and over the weekend, you were able to get MATLAB up and running on your computer. And today we're going to kind of look at how this thing works and look at some of the easy uses for this. This is like a big, huge software that is used in universities and industry. It drives almost all of the work that's done in applied mathematics, so you're using the industry standard software here. If you look at your screen, there's three major components here. There is a set of folders. That's not something we're going to touch right away. As you get into ACalc and linear next year, we're actually going to look at some of the programs that are here in mine, and I'm going to teach you how to load those into yours. Here on the screen is what's called the console. The console is the place where you do most of your work. So like if you click that and activate it, a little cursor comes up and you can type in there. Down here is what's called the workspace. This is where you see all of the variables that you've defined, and we'll see that as we're moving along. On some level, MATLAB can be used just like a calculator. You can type in 3 plus 2, you hit enter, and it tells you that the value is 5, right? 4 minus 6, I hit enter, I get -2. Multiplication gets a little bit wonky here, and division and taking a power. The native object inside of MATLAB is actually a matrix. That's what the MAT in MATLAB stands for. It's like matrix laboratory. So numbers are not the normal thing that gets used in here, and we'll take a look at that as we're going through in the next year or so to get some idea of what's going on there. So multiplication of matrices and multiplication of numbers is different. When you do multiplication in MATLAB, it assumes matrix multiplication. So what you're going to do here is you're going to add a little dot whenever you multiply, divide, or take a power. So if I want 6 times 5, I go 6 dot times, the asterisk for times, 5, and it tells me that that's 30. Divide, 12 dot slash 2, tells me that that's 6. 4 to the power of 2, 4 dot caret to the power of 2, 16. Okay, now you're noticing like everything's stringing in the console. So if I want to clear the console, I type CLC, and that brings me back up to the top. Now, we're going to start dealing with variables. If I type clear, it clears out all the variables. CLC clears the console again, and I'm just like where I started. Okay, so we're going to create a variable called A, and we're going to give it the value 7. So A is like a container, and 7 is something that I'm sticking into that. Okay, now you're going to look in your workspace over here, and it's going to tell you that it made a 1-by-1 matrix, which is basically a number, and it put 7 in that space. So A is a matrix that has a value of 7. Alright, so let's make another one. B is 9. And it made another variable over there. Made one called B, gave it the value 9. So if I ask it what is A plus B, MATLAB tells me that it's 16, because 7 plus 9 is 16. Now you're noticing that it just created another variable over here called ants. Okay, and ants, according to this, is 16. So like if I want to modify that answer, if I take ants plus 19, it adds that 16 to the 19, and then makes ants equal to 35. Alright, so let's make c equal to 2, and then let's say c times a plus b in parentheses. It's going to follow the order of operations. It's going to add a and b first, and then multiply that by c, and we end up with 32. Okay? Alright, so let's clear out our variables. Clear our screen. Okay. And I want to look at logs and the exponential function, because they don't do what you think they should do. Normally, if I take log of 1,000 on my calculator, I would expect to get 3, because 10 to the third is 3. If I do this, I get 6.9078. What is that? Okay, so because mathematicians tend to use the natural log a lot, in MATLAB, log actually means the natural log. So like if I take the natural log of 1,000, and you could check this against your calculator, you're going to get 6.9078. So that's what you would normally think of as ln. If you want what would be on the log button on your calculator, you have to take log 10 of 1,000. That says take log base 10, and that gives me the 3 that I expected. 10 to the third is 1,000. This will also work for log 2. Log base 2 of 8. So 2 to the third is 8. So this should be 3. Now, it doesn't work for other numbers though. So like if I take log base 3 of 27, it says, I don't know what log 3 is. I'm confused. Did you mean the natural log of 27? Which is not what I meant. So I'm going to back that out of there. Alright. So another thing that we're used to is e having a value. Okay? We'd like e to be able to go e squared and get a number. And MATLAB yells at me. It says it's an undefined function or variable at e. Because it's thinking e is a variable. Like I can make e equal to 90. And now e has a variable. And if I take e squared, I don't get e squared. I get 8100, which is 90 squared. So e is just like any other letter here. So how do I get e squared? Okay, MATLAB has a function in it for the exponential function, e to the x. It's exp. Exp of 2 is e squared, which is about 7.3891. You want to prove this, just go exp of 1, and you should get that 2.718 that we're used to for e. E to the first is e. It's around 2.718. Another quick trick that works for like powers is like if you want to take 10 squared, you can actually type in either 10.2, which will give you 10 squared, or you can take power 10 to the second power 10 gives me 10 squared. So either way, that works. Okay, so let's get into some of the power of MATLAB here. So I'm going to again clear my screen and clear the console. All my variables are reset. And I'm going to create what's called a symbolic variable. I'm going to create 3 of them. So the command for creating symbolic variables is syms, S-Y-M-S. I'm going to do syms-x. It's going to take a minute because it's got to make that work. Syms-y. And syms-c. So if you look down here, it told me I just made 3 one-by-one symbolic variables. Now, none of these have values. So if I take x plus y, it just gives me back x plus y. If I take c times x plus y, it tells me I have c times x plus y. I can make d equal to c times x plus y, and now, whoop, the dot's on the wrong side there, times x plus y. Now d is equal to c times x plus y. If I d again, it tells me it's still c times x plus y. Alright, so why is this useful? Well, because I can do symbolic arithmetic here. Okay, so like if I took d plus x, it's now going to give me x plus c times x plus y, right? So let's clear the console, and we're going to clear the screen, and we're going to create a symbolic variable, sims x. And I'm going to create a function. We're going to say f is 2 times x squared plus 6 times x. Okay, there it is. Now, here's the magic of MATLAB. So that's 2x squared plus 6x. The command word for taking a symbolic derivative is diff, D-I-F-F. And I'm going to take the derivative of f. So the derivative of 2x squared plus 6x, MATLAB tells me is 4x plus 6. It just did symbolic differentiation. Okay, so let's create another function. Let's say that g is the sine of x. Let's diff g. Takes it a minute, maybe. There it goes. It tells me that g is the cosine of x. Kind of nice. If I make h equal to diff g, h is now the cosine of x. Here's another command that's useful. If I type subs, okay, so I'm going to substitute into h, and I'm going to substitute, so into the h function, I'm going to substitute into the variable x, and I'm going to substitute the value, and I'm going to put in pi. And actually, to do pi, I just type in pi. So this should be putting pi into x in h, so I should be taking the cosine of pi, which should be -1. And it tells me that I get -1. So that's derivative. It would be nice if we could do this with an integral. Let's see if we can do that. So clear CLC. We're going to create a symbolic variable called x. We're going to create a function. F is going to be 2x squared plus 6x. Okay. Now, the command for taking an integral is int. This is for taking an indefinite integral, int f. And it gives me this weird way of writing the answer. It says the quantity x squared plus 2 times 2x plus 9 all over 3. Now, if you simplify that, you're going to see that that gets you the same value that you're accustomed to. MATLAB just has sometimes a really weird syntax for writing out things when they're simplified. So I just want to make that aware of you, make you aware of that. However, let's say I make g equal to the cosine of x. Now, we know that the indefinite integral of the cosine should take me back to, well, let's see. Let's take the indefinite integral of cosine, and it tells me I go back to sine. So, that's the indefinite integral being done symbolically. Now, your calculator can't do that. That's not going to happen. Your calculator can do the definite integral. Definite integral works a little bit differently in MATLAB, so let's kind of get into that a little bit. So, we're going to create what's called a function handle here. So I cleared and I CLC'd. So my function handle says f is at x. At x. And then it's going to be 2x squared plus 6x. Oops. X times. There we go. I'm missing the times all over the place. There we go. 2x squared, and I missed the dot before the square, so I should probably fix that too. There we go. 2x squared plus 6x. Alright. So, what did I just do? Well, see, if I take f of 5, it now works like a function. Because 5 squared is 25 times 2 is 50, 6 times 5 is 30, 30 and 50 is 80. So it just evaluated the function at the value 5. Now what I can use, now note, when I did indefinite integral, I used int. To do a definite integral, I actually use the word integral, I-N-T-E-G-R-A-L. I'm going to take the integral of f. I'm going to take it from 0 to 2, and it gives me 17 and a third. So if I took the integral from 0 to 2 of 2x squared plus 6x, it comes out as 17 and a third. You could try it, work it out by hand, work it with your calculator, see what happens there. Alright. The other one is, let's say g is at x. So I'm making this handle of the cosine of x, right? So, like if I take g of 0, I should get 1, right? There we go. Okay, so let's take integral of g of 0 to pi. Now, the integral from 0 to pi of the cosine, if you stop and think about it, it should be 0. MATLAB's going to do something weird here. It gives me this 1.11 times 0.2 times 10 to the negative 16th. Okay, why did it do that? Well, let's talk about that for a second. Okay, so why is this happening? This is happening because your computer can only represent things so well. And realistically, what your computer is doing in order to calculate this integral is it's using what you know is a Riemann sum. It's doing it with a really narrow width for each partition, and it is coming up with an estimate. Now, that estimate's really accurate, and it's usually accurate to 15, 16 decimal places. So if you look at this number and you say, oh wow, this is accurate to 15 or 16 decimal places, that's a really funny way of writing 0. 1.11, if you get a number from MATLAB that has like an e to the negative 15 or an e to the negative 16, that's machine precision. And using a numeric method, that's as close as it's going to get. So this is a funny way of writing 0. So I wanted to show you that. Now, is it actually getting the integral correct? So let's do something where we know we're not going to get 0. G from 0 to pi over 2, right? So I'm going to take the integral of the cosine from 0 to pi over 2, and that gave me 1 with a whole bunch of zeros, but it's 1 and then 0, 16 decimal place type stuff, right? So remember, the computer is actually using a numeric method, probably either a trapezoidal rule or some sort of Riemann sum to get you the value for the definite integral. It's just doing it really fast. Alright, so there's an introduction to MATLAB. Your job today is to just play, try to make it work for you. If there's something that you're trying to do with MATLAB and you can't figure it out, usually the best idea is actually just Google it, because this thing is so used so broadly, so everywhere, that anything you're trying to do, somebody else has already tried to do. And usually if you Google for it, it's going to give you a pretty good idea of where to go with it. All right, so thank you. Hope you're having a great day.